All right, this part of the video is just to show you the almost seems unexpected results that recursive methods can be. So you'll see that recursive methods here, I called it recursive, but you don't have to. This is the method right here. It's called mystery 1. And inside mystery 1, there is a call to itself. So it's literally calling itself. And when it calls itself, crazy, wonderful, amazing things happen. Just realize that every recursive statement, every time you have a recursive statement, it needs to be in a condition of some sort. So it has to be in an if statement so that the recursion actually ends. So if you just have a recursive call inside a method with no condition, it will run forever and, crash your computer quite quickly. Okay, so I'm going to go through the tracing of these so you can see how they work, but I just want to show you these methods actually run on the computer. So what happens if I run this, it ends right here. So mystery 1, it does 5-2, it outputs 5-2, and then when it calls itself, it goes down to 4. So then it calls 4-2, then it calls itself again, and 4 down 1 goes 3. Now when I get down to 2-2, this condition is no longer met, and recursion is over. So it actually goes down here. There's no recursive call in this one. It's actually the same exact thing if I remove the else, because if this doesn't work, it's going to do this. And then sorry, let me just keep my else there. It's not exactly the same. So then it's over. So then it comes down here and finishes these methods. So this is mystery 1. It finished up to here. It's to this line. So then when it finishes, when the recursion is over, when the condition has failed, it has to finish the method. And when it finishes it in reverse order. So what happens when I start doing math in this, or any sort of searching, those kinds of things that this is actually useful for. So if I call mystery 255 and I run this guy, I get 27. So we're going to trace this and see where the 27 comes from. Okay, but you're adding k. K is in this case 5, so you're having a 2 here, so you can kind of maybe see where the 27 comes from, but I'm going to trace through it so you can see how that works. But notice that this is one of those things that can be done. And then finally this one. Okay, please note when you watch this on the video that I did the tracing before I actually ran the programs. Go me. And I got 12 because I can't add 8 and 5. But with this one, sorry, I was just trying to figure out why I got 12 a second ago. Why? Because 8 and 5 is 13. Okay, and you'll see that in a couple minutes. So with this one, it actually has 2 calls. So in each method that you call, so each one of these is going to have 2 calls to itself. So it creates this branching situation that is actually really good in computers, because lots of branches and file folders and memory locations, and that's why recursion can be of use. Okay, so you're going to watch me trace these and have a great time doing it. Have a good day.